Okay, section 14.5, simplifying complex fractions. Let's take a look at these. Obviously they look very complex, but let's remember how we should be thinking of these. I'm going to give you just a very simple fraction over here on the side here. We've got 1/2 divided by 2/4. Remember, this right here, this line, that still just means divide. Okay, so if I wanted to rewrite this, I could always rewrite this in this form. I could say, okay, well, I basically have 1/2 divided by 2/4, but we also know that we can't divide, so this is going to equal 1/2 times 4/2. Okay, and that crosses out. You've got 2/2, which all this is going to end up equaling 1. Okay. This works exactly the same way. Notice right here, we can just take these and we're going to start flipping these around, okay? And then we're going to be paying very special close to things that look like that, okay? Because when you have a negative power, this is exactly what happens to it. But like I said, we're going to be doing a bunch of those in the examples. So to simplify complex fractions, first method, simplify the numerator so that it has a single rational expression. Simplify the denominator so that it has a single rational expression. Okay, and divide the numerator and reduce the lowest term. Okay, so let's start looking at this one here. Let's go ahead and rewrite this into something we can understand. We are going to have 3x all over y squared divided by 12x all over 7y. Well, this is the same thing as saying 3x all over y squared divided by 12x all over 7y, which once again is equal to, because we don't divide fractions, we multiply by the reciprocal. So we're going to multiply this by 7y all over 12x. Double check everything. Yes, it all looks good. Now, before I start doing anything else, I'm going to go ahead and reduce my coefficients here. That's going to be a 1. This right here is going to turn into a 4. Now what you can do is you can multiply straight across to go ahead and make this thing just a little bit easier to look at. Instead of you can go ahead and do your reducing now. If you're comfortable with it, go ahead. Okay, notice here, at the very top, I'm going to end up having 7xy all over, well, I've got this y squared, I got a 4, and I got an x, so I've got 4xy squared. Okay, well, let's start to see what can reduce. Well, I've got this x here, that's going to be gone. My coefficients, those can be reduced. I've got this I've got 2 y's on the bottom, 1 on top, so I've got 1 here, and then I've got 1 minus 2. Well, continuing on with my simplification process, that's going to give me 7 all over 4 with a y to the negative 1. Well, remember, whenever you have a negative power here, I'm going to get the highlight right here. Whenever I have a negative power here, that means that and that all goes to the bottom. Okay, this all gets shifted down to here. Okay, so, and vice versa. If you had a negative power on the bottom, it would get shifted up to the top. So my final answer for this one is going to be 7 and 4y. All right, let's continue on. One more example. Okay, to simplify complex fractions, second method. By the way, on this second method, I'm going to be showing you that more through the examples in your notes and on your Hawks lesson. So we'll just go ahead and read through 1 through 3 here, then I'll show you just one more example of just kind of just doing the other method. Because this second method works a lot better whenever you just have larger fractions other than the one I've got here. So find the LCM of all denominators in the numerator and denominator of complex fraction. Multiply both the numerator and denominator of the complex fraction by this LCM. And simplify both the numerator and denominator to reduce the lowest terms. Okay, like I said, I will show that in the notes. Matter of fact, I'll put that in there. Okay, shown in examples. Okay, let's look at this one though. This is going to be one of those other easy ones again. This is going to be x squared all over y to the third. Okay, divided by, because remember we'll bring that up, I'm going to have 3x over 4y, which is the same thing as saying x squared all over y to the third multiplied by 4y all over 3x. Okay, let's take a look at this one a lot more carefully now. Notice, remember, you can cross reduce. Okay, so doing that, I can come in here and go, okay, well look, I've got an x here, and then I've got two x's up here. Well, that's just going to leave me with 1x. Here I have 3 y's. Here I have 1 y, so I'm going to subtract 3 from over here. Okay, so whenever I continue this on, I'm going to end up having, let me switch back here. Well, let's go ahead and just multiply all this out. I'm going to have 4. All of this is gone except for the 3 on the bottom. I'm going to have 4x y. Okay, well, what's 1 minus 3? That's going to end up being a negative 2 all over 3. But remember, whenever you have a negative on the bottom like that, you're going to end up having, you're going to end up taking that and pushing it down to the bottom. So we're going to take this guy and push it down to here. So our final answer for this one is going to be 4x all over 3y squared. Okay, so there you go. And like I said, I'm going to be showing you the second method in your Hawks notes. It'll be listed down below in your notes section and also on the examples we do in class. So there you go.